Okay, so welcome student for the another video lecture. This is the continuation for the previous lecture, that is lecture number 5. We are discussing about the probability distribution, and in this case we are discussing the fifth number of the distribution, that is called the exponential distribution. Now in this case the formula for calculation of the exponential distribution is lambda e raised to power lambda x, where lambda is calculated as 1 divided by the mean value. Okay, so that you have to remember. Now let us understand the exponential distribution by taking some examples. The first example is the mileage which car owners get with certain kind of the radial tires is a random variable with mean is equal to 40. Okay, so mean value is given as 40. So from this mean value we can calculate the value of lambda. So lambda value is becomes 1 divided by the 40. Okay, so that value we got here. Now the next the find the probability that one of these tire will last. So from the first of all we'll develop the formula fx is equal to, so fx is equal to 1 divided by 40, so that is equal to lambda, and e raised to power lambda multiplied by x, e raised to power lambda, so lambda multiplied by x, so this is minus x upon 40. Okay, so e raised to power minus lambda multiplied by x, lambda value it is minus value, it is minus. Okay, minus lambda is 1 by 40 and x. So this is the fx value is there. Now we will take the first case, at least 20,000 kilometer. Okay, so at least means what? It is greater than or equal to 20,000. Okay, so uh, the all things we are taking, so in terms of the kilometer, so so x value is equal to 20. Okay, so here we are taking in term that is the not the 20,000, 30,000. So in terms of 0 kilometers, so that's why not one, only 10. So 20 here, so 20 value. Okay, because the value will become very large then. So x is greater than or equal to 20. Okay, now the formula for the calculation of this fx. Okay, so that value is equal to the integral. Okay, 1 upon the lambda e raised to power minus x upon 40. Okay, dx. Okay, dx. Now what is the lower limit and the upper limit for this one? So uh, this is greater than or equal to 20. So this is the 20 value. Now we have discussed in previous case, in previous examples, there the lower limit is given in the problem. Now here the upper limit is not given, so that we have to take as a infinity. So it goes up to infinity. Now how to calculate this value? So the constant, it comes outside the bracket, e raised to power minus x divided by 40 and minus 1 upon 40. Okay, if we take the integral of that one, so it goes from 20 to infinity. So if you calculate this value, so this comes out to be e raised to power minus infinity minus e raised to power minus 1 by 2. So if you calculate this value, so this value comes out to be 0.6065. Okay, so this is the answer for the first question. Now for the second one, uh, the at most 30,000 kilometer. At most means what? It is less than 30. It is less than 30,000 kilometer. Okay, so less than 30. Okay, less than 30. That means the lower limit is equal to 0 and upper limit is equal to 30. Okay, so x will start from 0, it goes to 30. The higher limit for any range of kilometer, that is equal to infinity. So this is equal to 1 by 40. The same formula here, x raised to power 40 and dx. So if you calculate this value, so this value comes out to be 0.5276. Okay, same the integral, and if you put the lower limit and upper limit, you will get the answer as 0.5276. Okay, so this is the answer for the first problem. Now let us take the second problem to understand the exponential distribution. The lifetime of the microprocessor is exponentially distributed with mean 3000 hours. So mean is given 3000 hours, so lambda is equal to 1 upon 3000. So lambda value is equal to 1 upon mean. So that we have calculated. So here how to define the function fx. So 1 upon lambda, so 1 upon 3000 e raised to power minus lambda, lambda is equal to 3000 and multiplied by x. Okay, multiplied by x. So x upon 3000 dx. So this is the formula for calculation of the exponential distribution. Now let us take the first the case. Microprocessors will fail within 300 hours. Within 300 the hours. So that means the probability distribution is less than or equal to 300. That means it goes only up to 300 hours. So here it is 0 and upper limit is equal to 300. So it start from 0, it only goes up to 300, and this 3000 e raised to power minus x upon 3000. So if you calculate this value comes out to be 0.0951. Okay. The second case is microprocessor will function for more than 6000 hours. More than means p is equal to x is greater than or equal to 6000 hours. Now when it goes 6000 more than 6000 hours, so the upper limit will be the infinity. Okay, the same thing you have to write down here. So 1 upon 3000 multiplied by e raised to power minus x divided by 3000. Okay, 3000 dx. Okay, and if you calculate this the integral, so that value of the integral will comes out to be 1353. So you have to understand the meaning of the sentence. So when it fails within 300 hours, so it starts from minimum 0 to 300. When it for more than 6000 hours, so it will go from 6000 to infinity. So I think you will understand the problem. So that is depends upon the exponential distribution. The formula is very simple. The formula is fx is equal to 1 upon the this is lambda that is equal to 1 upon mean multiplied by e raised to power minus 1 upon lambda x. Okay, so this is the formula for calculation of the exponential distribution. Okay. Okay, so that is another distribution that is comes in the series of probability distribution is the gamma distribution. To calculate the gamma distribution, the formula is fx lambda raised to power alpha x alpha minus 1 e raised to power lambda x. The probability of alpha. Okay, sorry, the factorial of the alpha. Now, how to calculate this? In a city, we will take the example. This is the factorial. Okay, so this comes something like this: alpha. In a city, consumption of power in a day is a gamma variable with parameter alpha is given 1 by 2. Alpha is equal to 4. Okay, so we can write down the function fx. So fx is written something like this. So this is 1 by 2 alpha. There is lambda. Lambda is equal to 1 by 2. Alpha is equal to 4. So this is 4. Then we have x is unknown. Then this is 4 minus 1. Alpha minus 1. Alpha is equal to 4. E raised to power minus x by 2. Okay, because alpha is equal to 1 by 2. Now divided by factorial 4. So factorial 4 is 6, and from here, so we will get, if we calculate this, it comes out to be 1 by 96 x cube e raised to power minus x by 2. Okay, for x greater than 0. Okay, then afterwards, what we have to find out, the condition is that the city has the daily power consumption of 12 mkWh. Find the probability that power supply is generated on any randomly selected day. So we have to find out the probability for x is greater than 12. Okay, so that means the daily power consumption should be at least 12 mkWh. So we have to find out it is greater than 12. Okay, so for this, how to calculate this? So what we have to do, we have to take the integration of this. So minimum limit, lower limit of this function is the 12, and maximum limit will be infinity. Okay, so for this fx function, we have to use this lower limit and upper limit, and then we have to integrate this equation. If you integrate this equation, so it comes out to be 1 by 96. Then it comes out to be x cube in bracket e raised to power minus x by 2 divided by 1 by, I am taking the integral of that function, then this is minus 3x square in bracket e raised to power minus x by 2 1 by 4. Okay, then plus 6x e raised to power minus x by 2 minus 1 by 8. Okay, uh, then we have minus 6 e raised to power minus x by 2 divided by 1 by 16. Okay, and here the limit, lower limit is 12, upper limit is infinity. Now put the lower limit and the upper limit in this equation, and then finally we have to calculate the answer. So if you solve this the equation, so the final answer will come out to be 1.1512. Okay, so this is the method for calculation of the gamma distribution using the formula mentioned here. So for all the distributions you have to remember the formula, so that is important. And then sometimes they will ask what is the gamma distribution, explain with the help of the example, or numerical will be asked for 6 to 7 marks. Okay, so next distribution is the normal distribution, or it is also called as the Gaussian distributions or the bell curve. The formula for calculation of the normal distribution that is given here, 1 upon sigma under root 2 pi e raised to power minus x minus mu square to sigma square, where mu is the mean, sigma is the standard deviation, pi value and e value is given here. Now here we have to again find out the standard normal variant, that is called as the z, that is given as the x minus mu divided by the sigma. Now this is called as the mean, median or the mode. This is the area is 1 for the curve, that is 0.5 on the left hand side and 0.5 on the right hand side. Okay, so this area can be defined here. Okay, now let us discuss the normal distribution using the example. So an electrical firm manufactures light bulb that have life before burnout, that is normally distributed with mean 800 hours. So mean is that is equal to mu, that value is given here, and a standard deviation, that is sigma, that is equal to 40. Find the probability that the bulb burns. Okay, so more than 834 hours between, and second one is between 778 and 834 hours. Given that these values are given, we have to use this value. We will see how to calculate. Suppose the normal distribution will be something like this. So this is mean, so the value of mean is equal to, this is the 800. Now for first case, what we have to find out? We have to find out the probability 834 hours. So the x is greater than 834. Okay, so here somewhere we have 834 here. Okay, so that is the value. So we have now 3 regions. So this is one, this is the second one, and this one is the third. Okay, we will calculate the value for value of the z here. So z, the value of the z can be calculated as, there is the probability only. So probability of z. So we have to calculate this value. So how to calculate that value? So first value will be, so formula for z is x minus mu. So what is the value of mu? It is 800 and divided by sigma. So first value for 800 it is 0. Okay, so this becomes 0 z, because 800 minus 800 divided by 40. Second value for 834 minus 800 divided by 40. So this value comes out to be 0.85. So z greater than, here it is 0.85. So this becomes 0.85. Okay, this is for the z value. This is the z value. Now this is the region 0 to 0.85. So if you see here, probability of 0 less than z less than 0.5, the area is given. So this is 0.3023, and we know that the complete area on this side is equal to 0.5. So area for these 3 can be calculated as 0.5 minus 0.3023. So that value comes that value comes out to be
23. So that's
point
not quite
1977. Okay, let me calculate that value. So it will come out to be 0.1977. Yes, this is 0.1977. Okay. So how we have calculated this value? First of all, the required condition we have mentioned. We have calculated the value of z using the formula x minus lambda divided by sigma. So that value comes out to be 0.85. Then we have checked the probability distribution that is given in the problem. Between 0 to 0.85, the value is given 0.3023. We have to find out the value between greater than 835. That means we have to find out the area 3. On this side, right hand side, the area is 0.5. So 0.5 minus area 2 that is given in the problem to us. We have minus that value. So we got the required answer for the first case. Okay. Okay, so now let us take the second case. Now here in for the second case, we have to find out the probability between 778 less than x less than 834. So for this we will draw the normal distribution. So this is 778. Okay, this is 800. Okay, and this is 834. Okay, so this is our area number, suppose this is area number 1 and this is our area number 2. Okay, we will calculate the value z value for this one. So z value, if you calculate the z value for 778 minus 800 divided by 40, so this comes out to be minus 0.55 less than z, and 834 we already calculated that value, so that value is equal to 0.85. Now if you check these values, minus 0.55 less than z, so minus 0.55 less than z, so this value is given here. So that value is equal to how much? This value is equal to 0.2088. Now plus that is for the for this region. Okay, so this is 0. This is the z value, so 0, this is minus 0.55, and this is what, 0.85. Okay, now 0 to 0.85, 0 to 0.85, so 0 to 0.85, so this is this value. So already we have taken that value, 0.3023. So z less than 0.85, so up to here that value is given 0.3085, and minus 0.55, so this value, that is value. So we have to add these two regions, that is first region and second region values are given. We have to add this value, and the final answer becomes 5111. Okay, so this is the normal distribution for the given question. Okay, so what we have to do here, instead of using the formula, that means the main formula, we have to use the formula for z. Using z formula, the values for probability for the z is given here. Using that, we can locate the area, and the unknown area can be calculated. Just remember, on both the side, left and right hand side, the area is 50%, that is 0.5. So if the unknown areas are there, you can minus that area from the 50% area. Okay. Now the last distribution in the probability distribution series is the chi-square distribution. In this case, they will ask you the theory based on the chi-square distribution, because in the problem we have to use this chi-square distribution table. So that if that table is not given in the problem, it is difficult to solve the question. But the theory